So good morning guys, my name is Arjun Sharma and this is my YouTube project. My project is actually about liquid crystals. Liquid crystals is a branch of soft matter with properties between those of conventional liquids and solids. They're generally organic molecules, however they can be used in a variety of applications as a combination of organic and inorganic molecules. They're actually widely used in LCD displays, particularly in electronics, such as iPhone, watches, calculators, and your TV screens. So I have here a few examples. This is an example of a digital watch. It's a basic watch with a simple LCD display. I'm going to talk about how it works in a little bit later. On the other hand, we have sophisticated liquid crystals display such as the iPad, and if you can see, it consists of a highly complicated liquid crystal display with a combination of colors and a variety of contrast. So let's start. Liquid crystals were first observed when scientists were studying derivatives of cholesterol, such as cholesterol benzoate. Again, liquid crystals can be organic molecules, however, in electronics, they're generally used in combination with other inorganic molecules to give a variety of properties. Liquid crystals have two basic phases, nematic phases and chiral phases. Nematic phases consists of molecules which self-align to have a long-range directional order with their axis parallel. Chiral phases, on the other hand, have a sort of a twisting arrangement. Now, the important applications of liquid crystals, which makes it applicable in electronic display, are that these two phases can be interchanged by applying an electric voltage. So let's see how that works. Let's study polarization first. So what polarization is certain materials known as polarizers and when we pass unpolarized light through them, they allow light to travel only in a single plane. So in this case, for example, unpolarized light when passed through a horizontal filter or a polarizer becomes a plane polarized light in the horizontal direction. Similarly, in the vertical direction, we have vertical polarization. However, when I actually combine the two polarizers, there is no light on the other end when I pass unpolarized light, because both horizontal and vertical components of unpolarized light have been filtered out, including the other polarization planes, and hence we get no light at the other end. So now let's get started on how a liquid crystal display works. Now a basic liquid crystal display, such as this calculator over here, which I just dissected, consists of two polarizers, one in the horizontal direction and other on the vertical direction. It consists of two electrodes attached to the polarizers and a voltage source. Now, the middle of this arrangement consists of a liquid crystal. There may be many kinds of liquid crystals used. They may be used in conjunction with organic or inorganic molecules. At the back of the screen, we have a certain reflector. So if you can see over here in this calculator, I have, let's see at the back, I have electrodes coming in which supply the voltage or the current. And if I closely examine the screen of this calculator, I can see a liquid crystal arrangement in between. So if you can see over here. Alright, so now when there's no voltage applied between the electrodes, the molecules are actually in a chiral or twisted arrangement, and when light actually is passed through the back of the reflector, light can actually twist its way through and become parallel to the filter over here, and thus can pass through the screen, giving a clear appearance like this. Over here you can see a clear reflected light. On the other hand, if I have a voltage which is on, such as in this case, the liquid crystals actually arrange in a finite regular parallel arrangement, and as a result they become aligned with the polarization direction of this first polarizer. And now, since both polarizers are exactly in a perpendicular direction, light is actually blocked by these certain patterns. So if you can see over here, the digits on this calculator, the digits are actually what we see are the light which is actually blocked by the reflector. So as a result, we can see a 5 over here, which is actually light blocked by the liquid crystals. Now let's see a very interesting example of a special type of liquid crystals, which are known as thermochromatic liquid crystals. So I have with me a mood ring. Now this was pretty fashionable during the 70s. People would put them on their finger, and the liquid crystals here would actually respond to a temperature change on the finger, and as the color would change, people would sort of get an indication of their mood, which was highly artificially designed. There was actually no reason to believe that your mood could be decided on the basis of this ring. But as you can see, the liquid crystals here right now at normal human skin temperature are a shade of greenish blue and sort of purple, right? Now let's see what happens when I put it in a freezing cold ice bath. So I have an ice bath over here, and now let's see what happens when I place this in the ice. So if you can see, the color is gradually changing. It's becoming darker now. It's becoming more darker. And now it's completely black. It's very dark. On the other extreme, let's see what happens when I place this in this. This is boiling water, very close to boiling water. So I'm just going to drop it because it's very hot. And I'm just going to leave it for a few seconds. And now it's become a bluish color, a little bit different from the original color. Let's place it again in the ice bath, and it changes color again. So guys, I hope you enjoyed the video. See you next time. Bye.